everyone. So now we're actually going to do the lab. Hopefully you watched the first video. So I'm going to be reading the procedure to you and doing the steps. So step 1 says using an electronic balance, which we have right here. Using electronic balance, weigh your empty dry calorimeter, which is a coffee cup. So I am going to turn on, I have my scale here. Let me move my hydrochloric acid and stuff out of the way. You can see the scale. Here is our scale. I'm going to turn on the scale. This is the one that that is very sensitive, so we can't breathe. And I'm going to put my calorimeter, which is literally if you look, is literally a Dunkin' Donuts coffee cup. And I'm going to zero the scale to just cancel out anything that's been on there before. And I'm going to put it on the scale. And I'm going to record the data. So the mass of the dry calorimeter, which I'm reading from the scale, I don't know if you can see it there. Maybe you can, maybe you can't. But I am just reading a number. So the number on the mass of the dry calorimeter is 12.332. All right. So now we look at the instructions next. Okay, it says to remove it from the balance and pour approximately 40 milliliters of hydrochloric acid into it and weigh it again. Record these masses on the table. So here is again my calorimeter, and here is my graduated cylinder. And if you look here, this is the 1 molar hydrochloric acid. So I am going to pour the hydrochloric acid, and looking at the meniscus, you can see, but everything is me just measuring acid, the 40 milliliter mark. Need to pour a little bit out, so let me go to the sink. And then you add a little bit more. We're at like a drop. All right. So I am going to pour this into the calorimeter, as I'm doing right here, pouring the acid into the calorimeter. And I'm going to place the top back on, and I'm going to reweigh it. And I will put a picture of the data into the chat in Discord and on Google Classroom. So if you missed the numbers, you can get them. So with so I'm going to the data table, and I don't know if you can see it. Let's see. I don't want to like ruin my computer. Sorry guys, we're going to the meat tab. Lost the meat tab. So anyway, but I will just record it because, again, you're just looking at a number. So if I record the number, and my lab fell on the floor. So it now weighs, and if I look what it's weighing the cup, it now weighs 52.654 grams. These are all grams. So 52.654, and again, I will send you a picture of the data table. And so to get the mass of HCl used, you're going to subtract those two numbers. So you can do that yourself, guys. So to get the mass of HCl used in the data table, you are going to subtract 52.65 minus 12.332. To get the mass of HCl used. I don't feel like getting a calculator. I'll do that later. All right, so I'm going to take the calorimeter off and put it to the side for a second. And here I have my magnesium metal. So I am going to put a cup on the scale. Let's just use a beaker. I'm just going to use a cup. And I'm going to zero it. And I'm going to place so this is a magnesium metal, ribbon metal. I'm going to cut it into smaller pieces. By cutting it into smaller pieces, so this is now step 2. By cutting it into smaller pieces, it gives it more surface area so it can react more quickly. And we'll talk about that when we get to the kinetics unit. I'm just going to zero the scale again, and I'm going to cut small pieces of the metal. I'm just cutting right now pieces of the metal into this cup. So it's hard to hold up and do it at the same time. But again, I'm cutting the pieces of the metal into the plastic cup. And they're getting masked. All right, that's about a good amount, I would say. So the mass of metal that we're using, you can see the mass of metal using is 0.168 grams, 0.168 grams. And you can see what it looks like. It's just sort of strips of metal. That's magnesium. Okay, so if we go to the next part of the lab, it says place the lid on top of the coffee cup and place the thermometer in a hole. So there's a hole in this cup. And I'm going to place the thermometer in the hole. And it is going to measure the temperature of the water. I don't know if you can see the numbers. Hopefully you can. I don't know. But again, this is just measuring the temperature of the water. You know, the acid that's in here. I'm going to wait till it comes to an equilibrium temperature. So that means the numbers stop moving. So it's fluctuating between 21 and, we're going to say 21.0 is the initial temperature of the HCl. Okay, now, when you do this reaction, what I'm going to do is I'm going to pour the metal into the cup. And I have to keep the top on because that keeps the heat in. But when you naturally, and I'll show this to you at the end, when you naturally react metal with hydrochloric acid, and most metals, a lot of metals, especially group 2 metals and group 1 metals would explode. But they produce hydrogen gas. And so you would see bubbling if I lifted up the coffee lid top. But I do not want to do that because that's going to lose heat to the environment, and we don't want to do that. So I'm going to pour that in there. You may hear the bubbling. I'm going to hear the bubbling. I don't know if you are. It's going to bubble. You want to record the temperature to either you hear the bubbling stop, which means the reaction is done. Hopefully that's what we get. Otherwise, that means we didn't react well with magnesium and we're going to have error. Or until the temperature starts going down. This is an exothermic reaction, so the temperature is going to go up. So what I'm going to do now is I'm going to take my thermometer out for a second. Okay, and I am going to take the top out. I'm going to pour my metal sample into the cup. Right, in this reaction, I want to replace the top as soon as possible. And I'm going to put my thermometer back in. And if we look at what we have right now, we see that our temperature is going up. So we're at 23. And we want to stir a little bit so that the reaction occurs. 25. And I'm shaking it so that the reaction occurs. 27, 28. Stirring and shaking so that the reaction occurs. 30. 31. We're at 32. And again, the reaction is occurring inside the cup, hopefully keeping the heat in. 32. 35. Still going up. Reaction, I can still hear the sizzling. We're still going up. 36. And I can still hear the sizzling. Again, when the sizzling stops, I know the reaction is over, and I want to shake it a little bit to make sure all the pieces are reacting. Still going up. Reaction is still occurring. Shake, shake, shake. All right, we're going up slower now at 39. Bubbling is still occurring. I can hear it. 39.1, 2, 35. Oh, it went up to 40. Reaction is really starting to occur now. Shake a little bit. It's getting warm to the touch now. It's at 44. $51, so it's really still occurring. I think it just took a while to get started. $55, it's getting really warm to the touch now. 60, 62, oh, the reaction is occurring. All right, it's starting to go down now. So the highest I saw it reach was 60, looks like 61.4 was the highest I saw it reach. And I hear the bubbling has stopped. So the final temperature was 61.4. I'm just going to quickly get a beaker just to show you what the reaction looks like naturally. And like all of it is gone. If you look, there's no more. You can see there, and I don't want to pour over the computer, but let me actually move this down. So if you can see, there's no more metal in the cup. All the metal has reacted, which is what we wanted. It produces magnesium chloride, which is soluble in water, so you can't see it, it dissolves. So if we get a beaker, I just want to show you what this reaction looks like. So I'm going to pour a lot of hydrochloric acid into the beaker. And I'm going to take a big piece of metal and put it in there. So this is you see what was happening during the lab. And if you look here, you can see the bubble being produced. So that's the hydrogen gas. And you can see it being produced from the top. You can see it's coming off the ribbon. We did this in honors bio, but that's the hydrogen gas reacting. If I feel this is getting warm to the touch, so that means it's exothermic. So that's what was occurring inside the calorimeter, which you couldn't see. You can also see that the solution is getting cloudy. That is the production of magnesium chloride, which is a white solid. So it's producing so much that the water can't dissolve it all right away. And it's also, you can see, settling down to the bottom a little bit. And this will react either until, it depends on which one's in excess. Is the magnesium metal in excess, or is the acid in excess? I would guess the acid is in excess, but I'm not going to make you sit here and watch this. But again, it's bubbling, and it's producing magnesium chloride and hydrogen gas. That's the gas you see coming off the top, or the bubbles that you see producing. So I am now going to stop recording, and we're going to go do some data crunching. I will put the data table, I will hold it up so you can see the numbers. If you cannot see them, I will also put a picture in our classroom. I'm now going to stop recording. Hold on, I need to get my mouse.